All right. So what we have here, guys, we're gonna review some things that you should already know. All right. And most of them, I'm sure, as you were copying down the words, you were like, all right, I know what this is. All right. So the first one we have here is an ordered pair, also called a what? Also called a solution. What else? What is this? It's a coordinate. It's a point, right? So this is a point. This is a coordinate. Okay. So a point, a coordinate, a solution always has two parts: an x and a y. So now it says here that makes the equation true. What do I mean by that? What do I mean by makes the equation true? Quick example. If I gave you y equals x plus 2, and I told you the point 1 comma 3. Okay? Is that a solution? Well, let's just try. This represents my what? And this represents my? So if I plug in this for x, 1 plus 2, does it give me 3? So then is this a solution? Simple as that. It's true. Does that make sense? So then on the opposite side, if it wasn't true, it would be false. It would be false. And would that be a solution? Simple as that. Got it? So here we have intercepts. What are intercepts? Very simple. What does intercept means to cross, right? It means to cross. Any football players in here? When you intercept a pass, obviously the lines have to what? They have to meet. They have to cross, right? You can't intercept a pass on the other side of the field. You have to be right there. You have to cross paths. And that's exactly what it means. So we usually have two types of intercepts that we talk about: an X and a Y, right? So an X-intercept is where the graph touches the X-axis, and the Y-intercept is where the graph touches the Y-axis. Very simple. And just in case, which one's which? X is the horizontal, Y is the vertical, okay? And we're going to talk more in depth when we get to some examples. And going back to elementary, guys, what's symmetry? Symmetry means basically it's a line, right? It's always a line of symmetry. You've heard that before? It's always a line. So basically it's the line that you would cut something in half where it's the same on both sides, right? Like for instance, what if I gave you this graph right here? Okay? If I gave you that graph, would this be considered a line of symmetry? No. Would they be the same on the they kind of look similar, right? But they're actually opposites, right? But what if I gave you this graph and then I cut it like that? Would that be considered the line of symmetry? Yeah. See the difference? Okay? So, all right, let's do some math. Close your eyes. Let's do some math here. All right, so it says example 1. We're going to determine solutions. So very simply, are the following solutions of y equals 10x minus 7? So y equals 10x minus 7. Are they solutions? How would I do this? Yes. Simple as that, right? So what is it? What are these again? What is which? So this is my x and this is my y, right? So 2 is x and 13 is y. So Alexis here is saying just plug in x to see if we get y. Does that make sense? Okay, so first of all, you got to remember your equation is y equals 10x minus 7. So we're only going to mess with one of them, which is the what? The x. We're only going to mess with the x. So here's what we have. We have y equals 10 times 2 minus 7. 10 times 2 is? Minus 7 is? So y equals 2? 13. Is this true? Yes or no? Is this a solution? Is this a solution? Sorry. So the question was, is it a solution? Your answer is yes, this is a solution. Simple as that. Okay? Next one, I have -1, -3. I'm going to do the exact same thing because it's asking the exact same question. So this time it'll be y equals 10 times negative 1 minus 7. That would give me y equals negative 10 minus 7. Y equals negative 17. Be honest. Raise your hand. How many of you struggle with doing stuff like this? With adding and subtracting positive and negative numbers? Okay? Here's you might have struggles later. Here's what I like to think of, and it's because everybody knows how to deal with money. I think of when I think of positive negative numbers, I think of money. So positive means that I have money. Negative means that I owe money. That's the way it's because that's just the way the world works. You either have money, or you owe somebody money, right? So here's the way I like to think of it. Um, for instance, here. So imagine this was a money equation. Negative 10 means what? You already owe me 10 bucks. You're starting off owing me 10 bucks. And then when I say minus 7, I mean what? You owe me 7 more. I like that. It's 7 more. So you're going to owe me more than what you start. Does that make sense, right? So that's always, and it works, of course, with all big numbers. Doesn't matter with the numbers. Just, it's an easy way to think of it. If you have money, it's positive. If you owe money, it's negative or subtraction. Very simple, okay? Okay, I don't think we have to spend too much time on this. I think everybody kind of sat in the right seat at first after I shuffled you around a little bit. About graphing. Okay, so very simple. How do you sketch a graph? Well, first of all, you have to understand, and you can copy this if you want, or you can just kind of pay attention. If I gave you the equation y equals 7 minus 3x, if I gave you the equation y equals 7 minus 3x, the simplest and easiest way to sketch a graph is to do what? What do you need first? You need some points. You need some points, and the best way to get a point is through a table. So just set up a table. Set up a table. Now, here's the thing. I don't give you these, right? So these are basically, you choose them. You choose. Just choose some x's, and then once I get all the x's, how do I get my y's? You just plug them in, right? You just plug them in. So I didn't give these, but they're good. Now notice the symmetry. Do you see the symmetry of the points? Right, I did -2, so then I did a +2. I did -1, so I did a +1. And then 0 is right in the middle. 0 is always a good bet because at least it tells you where it's going to cross right in the middle, right? Right at the y-axis. So basically, guys, the simplest, easiest way to graph anything is to get some points. Get some points, right? So that's what I'm saying. I think you're all pretty good with that. Let's talk about intercepts, okay? Let's talk about intercepts. And we already talked about them before. We have two types of intercepts. A what? X and a Y. Okay, so now we're going to talk about how do you find them. How do you find an X and a Y intercept? Okay, so very simple. Here's the rule. I need you to write it down. To find an X intercept, all you simply do is set the Y equal to 0 and solve for X. Set the Y equal to 0 and solve for X. And vice versa, or same thing actually, for the y-intercept. To find the y-intercept, set the x equal to 0 and solve for y. I'll give you a couple seconds to write that down. It says here, to find the x-intercepts, set the y equal to 0, solve for x. To find the y-intercept, set the x equal to 0, solve for y. Guys, you got to remember that x-intercepts are where the graph touches the x-axis, y-intercepts are where the graph touches the y. Very simple, right? So let's try this, okay? Let's try this. Find the x and y-intercepts of the given equation. So, we have y equals x to the third power minus 4x. And I want to do two things here. I want to find the x-intercept, and I want to find the y-intercept. Okay? I'm going to let you choose. Which one you want to do first? Why? It's the easiest. What are we going to do again? So, again, remember, x is equal to 0. So if x is equal to 0, what is that going to look like? Well, that's going to look like this. Y equals 0 to the third power minus 4 times 0, which is 0. So my y-intercept is 0. My y-intercept is 0. So that's going to be simple enough. Now the x-intercept, that one's going to be a little bit tricky. Okay? Yes. So for the x-intercept, what do? So you know that y equals 0. So how's that going to look? Good. So I have 0 equals x to the third power minus 4x, correct? Now what? So your directions in the page before said to make y 0 and then what? Solve for x. Okay, so when I say the word solve, what do I mean? What am I telling you to do? Get x by itself. Very good. You need to get x by itself. Does everybody agree with that? So now, there's an issue here though. There's an issue. Because I have two x's. Are they the same x? No. And the only reason I know that they're not the same, because can I combine them? No. Why can't I combine them, first of all? They're not like terms. Very good. They're not like terms. One's a cubic, one's just a regular to the... What exponent does this one have? It has 1, right? So if they don't have the same exponent, they're not like terms, so you can't combine them. Everybody good with that? Fantastic. So then what else can I do? If I square it, remember I have to square everything. It's going to just make it actually more complicated. Okay, so good. Some students want to say, okay, well, I can put the 4x to the other side. Could I do that? Sure. Then what? No, it is possible. So here, guys, here's one of the rules. When you have something that is in both, so I have two different terms here, right? And they both have something in common. A what? They both have an x. So if they both have it, I can take it out. Does anybody know what that's called? Starts with an F. Factor. I can factor it out. So what I'm going to do here is I said they both have an x, correct? And I'm going to factor it out. So if I factor it out, if I take it out, what's left? If I take out, now remember, I only took out one x. If I take out one x from here, what's left? X squared minus 4. Does everybody agree with that? Okay? Is everybody okay with that one? So now, does everybody agree that I kind of did nothing at the same time? Because these are the exact same equation, right? These are the exact, and how would I know? Because if I were to actually multiply this out, wouldn't I end up with this? So I didn't, factoring is really, you're not like solving, you're just kind of rewriting it. But for a reason. Because now, here's what I have. What are these two things doing? It's being distributed, which is another way of, they're what? They're multiplying. They're multiplying. Okay? So now here's what, when I see this, here's what I see. I see the first thing times the second thing is equal to what? 0. So let me say that again. The first thing times the second thing is equal to 0. So I only have two things, right? Let's go back to elementary, when you first learn how to multiply. Okay? If you have two things and they're multiplying and they give you 0, how is that possible? There's only one way. One of them has to be 0. One or actually both of them, right? Because 0 times 0 is still 0. Does everybody agree with that? So if the first thing times the second thing is 0, then that should tell you that one or both are 0, right? So I can actually split this up. I can say, well, then the first thing is 0. And then I could say, well, then the second thing is 0. But look, there's one of my answers. X equals 0. That's 1. And now over here, it's more simple for me. So instead of looking at this, I'm looking at this simple equation over here. So how would I solve this? Add the 4. So I'll get x squared is equal to 4. And then how do I get rid of a squared? square root it. So if I square root both sides, x is equal to, I'm going to go punch your Algebra 2 teachers. Um, Guys, when you take what is a square root? What is this? When I tell you to square root, what are you doing? Say that again. I'm asking you what times itself will give me blah, blah, blah. Right? So if I say, what's the square root of 25? I'm asking you what times itself will give me 25. And your answer is? Okay. Remember, it's times itself, correct? So there's always a trick. And there's, I know why you're only telling me one answer. Anytime you square root, you always have two answers. You always have two answers. Positive and negative, whatever. Why? Because 2 times 2 is 4. But negative 2 times negative 2 is also 4. Does everybody agree with that? So from now on, when I ask you what's the square root of 25, your answer is positive and negative 5. Does that make sense? Okay? Now, I know exactly why you're so used to only giving me one, and it's something we're going to talk about in the next slide. Okay? So, how many answers do I have here? Who said it? How many answers do I have here? 3. 0, positive 2, and negative 2. Does that make sense? So this actually has 3 x-intercepts. Is that possible? Yeah, I can cross it 3 times. Simple as that. We good? All right. This is why you only gave me one answer when I asked you for the square root. You guys remember the Pythagorean theorem? Yeah. A squared plus b squared equals c squared. First of all, only works with what? Right triangles. Only works with right triangles, okay? I'll give you, so I'm sure most of you remember this. Some of you probably heard this, but I'm sure you don't have the formula memorized, and that's okay. You can copy that down, and we're going to talk about midpoint right here for a second. We only have about 10 more minutes anyway, so we'll get through maybe one, but I'll give you some. Great. So I said here, let's start with Pythagorean theorem, and it's very simple. Very simple. You should already, some of you probably already know the answer, but I want to do it algebraically real quick. What was I given? First of all, I kind of messed up. Well, no I didn't. This triangle, is it a right triangle? How do you know? See, so what if, so okay, so this is kind of a weird thing. If you read the directions, I tell you that it's a right triangle. If I didn't say that though, could you use the Pythagorean theorem? Why not? Because it only works for right triangles, right? And I don't know this is a right triangle because it does not have that little box. Now, you can't just say, oh, that I can just draw it in there. Why? Good. It could be like 91 or 90.1. And could you tell the difference between that and a 90? No, not even with a protractor. You probably wouldn't be able to tell the difference. So those things have to be said, okay? So I either have to tell you it's a right triangle, like I did, or I have to show you that it's a right triangle. So now with this fact, can I use Pythagorean theorem? Yeah. And which one, what was I given? A and B. How do you know it's A and B? They're my legs, right? They're my legs and not my hypotenuse. So it's real simple, guys. We're going to do 3 squared plus 4 squared equals to c squared. 3 squared is what? 4 squared is c squared. 9 plus 16 is 25 equals c squared. And if 25 is equal to c squared, how do I get c? So you square root both sides, and when you square root c squared, you get c. And when you square root 25, you get 5. Well, see, here's the deal. You are correct. I technically get 2 answers. But this is why. This is why when I ask you for square roots, you only give me one answer. Because y'all used to do Pythagorean theorem all day, every day in 7th and 8th grade, right? Why do I ignore the negative? when it comes to Pythagorean theorem. Say that again. We're talking about we're talking about a length of a side of a triangle, right? Can you ever have negative distance? No. That's why we basically just ignore it, right? And some people will argue, well, wait a minute, sir. If I walk this way 6 feet, right? I went 6 feet, right? And then if I go like this, isn't that negative? No. It's just a different direction, right? It's different direction. That's why, have you ever noticed, like, when they do, like, when they're going down into, like, the ocean, they never say it's negative 500 feet. They say 500 feet below sea level, right? Because you can't go negative distance. It's a positive distance, just in a different direction. All right. So this is the reason why. But your element or your middle school teachers or algebra 1 teacher never really explained, like, no. You do get two answers, but one of them you're just ignoring because it's not pertinent to the information what we're doing. Does that make sense? All right. All right, guys. I will